All right, let me zoom in. All right. So here's our DPM review sheet for Cosmos, HR diagram, and EM spectrum. Here we have our HR diagram that we just reviewed. We already know temperature increases from right to left and brightness increases from top to bottom. What is true of our sun compared to Spica in the HR diagram above? So here is Spica, and here is the sun. How will we describe Spica?
Hot and bright.
Hot and bright.
And it's in the main sequence.
And it's in the main sequence. How will we describe the sun?
Dim. It's dim and cool.
Okay, we can do dim or cool, or we can do average brightness, average temperature. So what is the correct answer? The correct answer is C. The sun is dimmer because it is below Spica, and it is cooler because it's further to the right. Number 2, which group of stars will be found in the lower left quadrant? Alright, so here are our quadrants. This is going to be lower left, so these are going to be the white dwarfs. Which group includes our sun?
Main sequence.
Main sequence is right here. These are the white dwarfs, these are the giants, and these are the supergiants. Which group of stars will be classified as cool and bright?
Supergiants.
Good job. Cool is on this side, bright is at the top, and those are the supergiants. Which letter represents where the sun is located?
A.
It is A. The sun is on the outer arm, like our solar system, the outer arm of the Milky Way. But the sun is the center of our solar system, so it would not be B. Okay? What force holds all the components of our galaxies together?
Gravitational forces.
Gravitational forces. So now we have this. Why do stars shine? Stars shine because they are able to convert energy from gravity into light. Fusion occurs when 2 or more atoms are joined together to make a larger atom. That's important. Stars get their power from nuclear fusion, and we know this already. Deep inside a star, hydrogen atoms are constantly being converted by fusion into helium atoms. Hydrogen atoms are becoming helium atoms, or they're being made into helium atoms. It's this process that generates the light and heat energy given off by stars, including the sun. This is what happens to the hydrogen gas in the core of a star, like the sun. Gravity causes extreme pressure, creating immense energy, allowing the hydrogen nuclei to collide, forming a helium atom. This is called nuclear fusion. Okay? What is the process that combines 2 or more atoms together to make a larger atom? Nuclear fusion. What element is converted to a bigger atom in the fusion process? Hydrogen becomes helium atom. So the one that's converted is hydrogen. Hydrogen is converted into helium. So then that's the answer for number 9. Hydrogen atoms are converted into what?
Helium.
Helium. Nuclear fusion is the process that makes the light and heat. Good job.
This going to be on what's it called? The test.
It's very possible. Okay, does everybody have this? So we got 15 minutes. I need to get through 4 pages. I want to make sure I can explain it and give you the answers. Okay, so before we start with question 11, what is this?
The spiral, that's our galaxy.
Good job. This is a spiral galaxy, just like the Milky Way, the one that we live in on the outer arm. So let's label the box first. What would the box represent?
Galaxy.
Universe.
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 Circle is galaxy, right?
The circle is the galaxy.
And then is our solar system.
Our solar system is the triangle.
And then our stars. No,
And
stars.
oh, I'm sorry, that's wrong.
Earth.
The star can be a star or a planet. Good job. So that's what I want you to do tomorrow. If you have a diagram, I need you to label first. So ranking by size, which shape would represent the celestial object above? Which shape represents this? Circle. Where is our star located in the Milky Way galaxy? On the outer arm. Where would our solar system be located? On the outer arm. Alright, true or false? And we're going to make them true if they are false. The sun is the planet located at the center of our solar system. True or false?
The sun is a planet located on
The sun is the planet located at the center
Yeah,
of
it is true.
The sun is a planet?
Oh, no.
Ah, the sun is a star. So this is false. What word are we going to cross out?
Planet.
And change it to
Stars.
star. Good job. Hi, baby. You sure? Okay. The sun is located in the center of a disc-shaped Milky Way galaxy.
False.
It's located where?
In the outer arm.
All right. The sun is the closest star to Earth.
Yes.
Japanese Russian.
It's the only Earth in the solar system.
I know this.
I don't care.
See what I said? I said, I know this.
Oh, I love you, but I'm sorry. I'm almost done. The sun is large in size compared to other stars. False.
It's small.
Good job. Or you can do small, or you can do average.
What's us?
It's big because it's close. Very good job. Can y'all see what I'm writing? I'll get a different color pen. Sorry. Alright. The sun appears brighter than any other stars in our galaxy. That is true. The sun is considered a supergiant. What kind of star is it? Main sequence. The sun produces energy through a nuclear reaction called nuclear fusion. That's true. So we just read that on that previous paragraph. The sun is approximately 5,500 Kelvin. It is true. So if we go here, well, there's no scale on here, but it is about 5,500. So that's true. The brightness of the sun is only determined by color.
No.
False. So it's determined by how,
Big.
not how big,
Close.
so size and distance. Okay? So I'm just going to add here size and distance. It can also be determined by its composition, like what is it made of, the helium atoms, the nuclear fusion. So it's not only determined, the brightness is not determined by the color. The brightness is by the size and the distance. The sun formed from a nebula.
Yeah, true.
That is true.
Nebula builds a star.
Great job. Let's go. 24. Which of the following is not true regarding a nebula?
A is wrong. B is wrong.
Well, no, okay, so we're looking for the one that is false. Is A true?
Yes.
Yes. It consists of gas and dust. Is that true?
Yes.
It's held together by gravitational forces.
No.
They are smaller than a solar system. So, this is the one that we were debating on a couple days ago with the nebula size. And that's something that we're revisiting because the whole time we've taught you that there are no nebula in our solar system. So I think that is making you guys think that, okay, they're not in our solar system, so they have to be bigger. And I don't think we conveyed that well. So for this one, just circle D. and then we'll come back to it.
Wait, what?
Circle that one as being the one that is false. True or false? Wavelength differentiates one wave from another.
Yes.
Yes, because the wavelength is how you know how much energy it has, what type of wave it is. If you look at a big wave, you know that is not a gamma wave. Okay? True or false? The electron is not responsible for the emission of visible light. That is false. With no electron moving away or towards the nucleus, we won't have visible light. (27) Which wave has the longest wavelength, lowest frequency, and is non-ionizing? All right, which one is it? This is radio. What does non-ionizing mean?
Harmful.
Not harmful. Good job. Which wave has the shortest wavelength?
Gamma rays.
Good job. Which EM wave has the most energy? Gamma. Gamma has the most energy because it has the shortest wavelength. Good job. Which EM wave has the least energy?
Radio.
Which EM wave is used by satellites to collect information about the universe? So microwaves, a microwave is background radiation. Satellites use radio waves. Using the diagram above, describe the relationship between wavelength and frequency. As frequency increases, what happens to wavelength? It decreases. Because if you look right here, energy is increasing from here to here. This isn't a really good picture. The one we looked at on the board a second ago shows the waves doing this and then getting really, really, really tight together. So this is going to be low energy to high energy, low frequency, high frequency, and then you can also look at the space between the wave.
The wavelength decreases?
Yes. As frequency increases, wavelength decreases. It's the opposite for temperature and brightness. They both increase or decrease together. Analyze the absorption spectra above and fill in the blanks with the words closer to or further away. If the absorption spectra shifts to the blue end of the spectra, the object will be moving closer to the object or observer, and if the absorption spectra shifts to the red end of the spectra, the observer is moving further away. Write two complete, I'm sorry? Yes. Write two complete sentences, leave the door open. Write two complete sentences to explain the red shift and blue shift diagram above. Okay? What we got?
Red shift goes right. Red shift goes left and the blue shift goes right.
Give me something else using our terms. Red shift is moving away, and what happens to the wavelength? Increases, because remember the slinky, if I pull the slinky apart, it's getting bigger, so red shift.
Also it spreads?
Yes. Red shift is moving which way?
Right.
Away or toward?
Away.
Away, and the wavelength is increasing. Blue shift is, good job, is moving towards, good job, and the wavelength is decreasing. All right. Any questions on that? All right, let's go to the next page. We only got about 6 minutes left. Oh, this is the last one. Look at God. We only got the paragraph left. Okay, we're going to make it. Okay. So now we're going to tell a story using fill in the blank, and let's see if we can do this together. Our universe consists of many blank, such...
Stars.
Well, let me finish it. Our universe consists of many blanks such as comets, meteors, asteroids, stars, planets, solar systems. All of those are what?
Electrons.
Celestial bodies. Such as comets, meteors, asteroids, stars, planets, solar system, galaxies, etc. Our galaxy, it should say is called, it's called the what?
Milky Way.
The Milky Way. We can cross out this one and the Milky Way.
Is that why they make that nasty Milky Way candy?
No, I think that's just, they made the candy and they just gave it the name. Our galaxy was here before that. Our galaxy is called the Milky Way galaxy, which is a spiral.
Wait, so are we doing that? Did we X them out?
I am, so that I know what words not to use again. In one of the outer arms of the Milky Way galaxy sits our solar system, which has one star known as the Sun. The Sun is a medium-sized star that is categorized as a main sequence. Star on the HR diagram. The Sun appears to be very bright because it is the closest star to Earth and is the one we are most familiar with. Our Sun generates energy from a nuclear reaction that fuses atomic nuclei in a process known as nuclear fusion. We can analyze our Sun and other stars in terms of brightness and good job.
Or luminosity.
Good job. Magnitude or luminosity. Those are all correct answers. Brightness and temperature on the HR diagram. Another tool scientists use to study and collect information on the components of the universe is the EM spectrum. Each wave on the EM spectrum has a different wavelength that differentiates it from other waves. For example, the only type of wave that we are able to see with the human eye is visible light. Thank you. This is referred to as a, not electron. This is referred to as a blank, which is released when this is referred to as a big bang, which is released. Photon.
What's a photon?
We talked about this whenever we show the electron moving away from the nucleus and it releases the photon. A photon, which is released when an electron falls down a level toward the nucleus. So when the electron moves toward the nucleus, does it gain or lose energy? It's moving to Cook Middle School. It loses energy. When the electron moves away from Cook Middle School, it gains. There we go. An electron falls down a level toward the nucleus of an atom. Light spectrum is the many different wavelengths of energy produced by a photon or light, which we see as the different colors of light. One of the uses of the spectra is to help scientists determine if objects are moving away from us. If the emission spectrum is shifted towards the red end of the spectrum, it contains wavelengths that appear to be getting longer. This is known as redshift. Alright, and we already know Let's go. Let's skip down. This is going to be Big Bang
Big Bang.
and expanding because the bell has rang. Thank you, guys.